Example 2, I call work questions. And in work questions, you have, for the most part, we'll do 2 people, but you could have 3 or 4 or 5 people who could all do the job on their own, but they find out if they do it with somebody else, it goes faster. So if you could mow a lawn in, let's say in 1 hour you mow 1/5 of the lawn, which means on your own, you could do it in 5 hours. It's a very big lawn, right? And, oh, Nico's got a riding mower, so in this very big lawn, in 1 hour, he could do 3/5 of it, which would mean kind of hard to figure out how long it would take you to figure out how much it would finish it on your own. But together, if you did 1/5 in an hour and you did 3/5 in an hour together, you would get 4/5 of it done. And it would probably take you just over an hour to do. So what we're going to do in these work questions is we are going to create a table for 1 unit of time and the fraction completed by each person and together. And this table is going to be probably a little bit simpler than, I think, our distance, speed, time with the formula. That's the most complicated table. This table is going to be simpler. And then from that table, create an equation and solve.
Hi, can I please have Ella to the office itself?
Yeah, sounds
Thank you.
good. So we're going to create an equation and solve. So we want to create a table for 1 unit of time. And we'll do this question and we'll do the one right beside it just so you get to see more than one example. Maybe it helps you understand what's going on. So in our table, we're going to put time here. And in our question, we're dealing in hours. So 1 unit of time would be 1 hour. Then the people in this question are Marissa, so we're going to look at Marissa's fraction. How much would she get done in 1 hour? She can do the whole thing in 3 hours. So how much would she get done in 1 hour? A third. Then Marissa's working with Roger. How much does Roger get done in 1 hour? This is what we don't know. We don't know how long it takes Roger to do it, so we don't know how long it would take him in 1 hour. This is where we're going to introduce our variable. And for time, often we use the variable t. So if it took Roger 7 hours, he would get 1/7 done. If it took him 5 hours, he would get 1/5 done. If it takes him t hours, it's going to be 1/t is how much he's going to get done in 1 hour. Now, how much do they get done together? So this will be our together fraction. How much do they get done in 1 hour? The whole thing, right? So 1/1. You could just write a 1, but they get the whole thing done in 1 hour. How does this let us set up an equation? This will always happen, that this on their own plus this on their own has to equal what they can do together. Does that make sense? Your fraction on your own, the other person's fraction on their own, has to equal what they get together. That allows us to write, and I'm going to leave a space there. And how do we solve a rational equation? Let's get a common denominator. Can you see that this one is missing a t and a t? This one's missing a 3 and a 3, and this one's missing a 3t and a 3t. And once you have that common denominator, you can multiply everything by 3t. That would all cancel out. And we're left with t plus 3 equals 3t. Combine my like terms. Divide both sides by 2. I think Roger's paintbrush is twice as thick as Marissa's. That's why he can paint twice as fast. Could be a possibility. It only takes him 1.5 hours to do it on his phone. Or maybe Marissa's just always on her phone. You're supposed to be working. So we're going to do the one off to the side, because this one, the together fraction was 1. I want to do one where the together fraction isn't quite 1. So you can decide how much notes you want to do on the one together, because you have the notes for this one, but we're going to create our table. Kira mows the lawn in 40 minutes. When they work together, they can mow it in 24 minutes. How long does it take Mark to do it on his own? So we set up our table for 1 unit of time. So we're going to start with time, and our units are minutes, so I'm going to put 1 minute here. Kira's fraction, Mark's fraction, and the together fraction. I like how my lines got progressively longer as I went. I got more aggressive. I don't know what happened there. There we go.
Trying to draw sideways.
Maybe. So if Kira mows the lawn in 40 minutes, does it make sense that she would get 1/40th done in 1 minute? We don't know Mark, so his time is t. He will get 1 teeth. Teeth? Is that how you add a th to t? You get teeth? Oh my goodness. Crazy. We should have used, I don't know if there's any letter that you can add th to that makes it nice. 1x, x, oh, that, no. I'm gonna stick with teeth. Okay, and they're together fraction. Well, they can do 24 minutes together. That means in 1 minute they will get 1/24th done. And again, if you set up this table, it'll always be their separate parts have to equal what they can do together. And we get 1/40 plus 1/t equals 1/24. And I'm going to show you some mental math strategies here that can help you with this, because we need a common denominator, and probably 40 and 24 makes your brain start to go, I don't know what a nice low common denominator would be. So what I'm going to do is I'm going to rewrite my 40 like, 40 and 24 both have a common factor of 8. So 40 is 8 times 5 plus 1/t. We'll leave a space there. And 24 is 8 times 3. If I break those up, then I'm like, the only number that's missing here is a 3. I'm also missing a t. So this one will be 3t and 3t. The numbers that are missing here are 3, 8, and 5. And then the last one, I'm missing a 5 and the t, and a 5 and the t. I can multiply by that denominator. Make them go away. Very nice. And I'm left with 3t plus 40 times 3, 120 equals 5t. Move the 3t over. Divide by 2. Is it Mark? Yep. What are our units? It takes 60 minutes on his own.
Didn't know my uncle was so bad at McDonald's.
I don't know.
I guess I am too.
5, 6, and 10. Circle those three. Try question number 5 right now.